Welcome to another episode video on my Raspberry Pi 1 Model B Plus with stacked upon it a serial Pi Plus board, which then connects this serial cable to Minicom serial terminal via USB to serial converter. Also connected is this Raspberry Pi camera, and a network cable to network, so I can use VNC, virtual network computing. Also attached, easy to see, is this grey band cable, which leads to this breadboard full of electronics and connected to some fischertechnik as well. The Raspberry Pi is running Raspbian Linux, specially made for the Raspberry Pi, and I am focusing on this part of the board. This part has analog to digital converter with some elements. This one is I2C. And by I2C I am controlling some LEDs through resistors, an additional LED from fischertechnik, another LED from fischertechnik, which is controlled by means of this switch. And there are currently two algorithms that I have created. One that is just running up and down, and by means of the switch, let me try to show you if everything works. So, and right, it doesn't. So I am afraid I have to intervene a bit. Happened before and will happen after. Let me plug the power, see if that works. And this is not a good sign for the rest of the experiment, because if this doesn't work, what does? So then I'll be running the program that I was about to run, and this is unfortunately not running either. Okay, the first program is that the LEDs just run this way or that way, depending on that switch. And the second program, which I can't show now either, is that it binary adds the LEDs, including this one, and this switch, when pressed, this LED lights up, and then it's supposed to go the other way. But last time I found out that my understanding of the last part of the algorithm doesn't work the way I envisioned, so I have to investigate how it actually goes. It's an example I took from the internet, so the algorithm isn't mine, but I'm adapting it like I adapt more programs to my own needs. Anyway, time to switch to screencast and see how I can get it to work, hopefully. Because it has been that I couldn't get it to work. Right, so once again, camera view right here, another camera view of the oscilloscope here, set to I2C, but the focus is not very good right now. Let me see if I can improve it. How about focusing the camera? That's even worse. Okay, let's keep it this way. Then the wiring program, and this is the part that I found out last time was the culprit, so I used everything in the same way, and then I thought, wait, if I count up to 256, then I should also count down from 256 and maybe do exactly the same. And that because 256 is a very nice binary number. Binary has the ground number 2 to the power 0, to the power 1, etc. up to 2 to the power infinity. But 2 to the power 56, or more appropriate, let's see if this works here. Yes, it works. So, and by the way, now I am using the serial connection to the Raspberry Pi to actually make a calculation. Okay, so 2 to the power 8 is 256, binary number. And this means that it is excellent for doing adding LEDs to maximum number. So I could actually do exactly this algorithm, but then counting down. The point is, should I leave this the same as here? And I think I make a mistake here. So what I need to do now, and then the question is, can I get the electronics to work? So I'm replacing the details. Alright, now they are exactly the same as this part. So if I count down the binary part, it might just work. If, and that's a very big if by now. So these shifts are nice. This may be good as well now. The only thing is, I want to show you on the camera, and that may be tricky this time. Anyway, this is C, so I have to compile it. First, save. I have here the compilation command already in place. So the GNU C compiler, GCC, source code, which is this one of course. Then output to keep things very clear, the same name. By the way, if you leave the -O out, it will still compile, but it goes to a general a.out. It will be a very general program, and that is standard. So if you don't want to do that, and if you compile multiple files, everything will compile to the same name. Not practical, not good. So -O output name. Then libraries. Wiring Pi, necessary for it to work. Library Pi GPIO, also necessary because this switch is dependent on that library. If you don't include that, it won't work. Then what I found out during compilation examples, it does need, and I had not expected that, real time. I still don't know what the real-time part is, but it does. Without a real-time inclusion or library addition, it won't work. P-thread, program thread. It is mystery to me why, but usually RT goes with P-thread. Anyway, compile. No errors. No errors is only telling that there are no C language errors in the program. It doesn't mean that the program works as you want it. So, this is the program right here. Go. And unfortunately, I don't see a thing apart from here. So I have to change the time base of the oscilloscope now. And now I am in the order of milliseconds, which in itself is alright. But this is not alright. So it happened before that this probe was the menace. And they are really next to each other. So why this isn't working is beyond me. I need to check again. Well, how irritating can that be? I reset this wire and I am pointing to this wire right here, and it is hard to see, but it is this wire. And it is well, rather thin, rather flexible, so even a slight touch can make or break the signal, unfortunately. Anyway, that is what is working now once again. However, as you can see, no LEDs going except for this one, and that is this, but this one is not I2C. It is just one wire here and one wire there, and that's it. So the wiring schematics haven't changed. I've reseated the plus multiple times and still it doesn't work. And I can touch them. And then suddenly they might start working. Not very likely though. And then you notice that the whole signal has gone again. Oh, no, it's not. Okay. Maybe too impatient, but the question is though, why does it work? And last time it was working kind of. But considering clock and data are alright, so I figured that this is alright, and then it should show this, but as I said, I can't show anything. What I could do is show just a signal on wires. I have two oscilloscope wires left, so that may be an idea to hook those up and see if there's any signal going through. So right now I2C working theoretically. Well, there's signal. Here there's nothing to see except that I added apart from these two probes which give these signals. Well, they don't give the signal, they receive the signal. I added these two. Where are those two probes attached to? Actually, not quite sure, but I think I attached them to I think these two resistors. So now the question is, what kind of signal do I expect? Do I have to expect? They are not brightly lit, so it is not a very strong voltage over it. So let me, with channel 4 highlighted, see if I can manage it. It's 2 volts. Okay, 1 volt per block. Same then with this one, 1 volt per block. This means that there is nothing going out. Nothing at all. That means that this chip doesn't do anything, because as I showed, when I have a probe here and a probe there or anywhere, these two LEDs are always lit because they add up. Well, they are not always lit, of course, because if you watch this, and assuming that these are the LEDs that lit first, it's 1 and the rest 0, and then you get 0 and 1 for 2, 1 1 for 3, and then this one is lit, and then these two are 0 again for 4. Unfortunately, I do not have enough probes to show them all, but what I might do is just pause the program. It has now the digit 512. Why does it have the 512? I am looking for the Y actually. Oh, Y is 108. Which means something that, wait, it's not the binary. This is not binary. This is just adding up. My mistake. And what is it doing with the first? This is 80. Why is 80 here? 81. It's just counting. Yeah, of course it's counting, because every digit that you see here, every LED, you can form any number you can form with binary numbers. So it's binary after all, of course. It's a binary adder. But what I should do is actually making just one happen. Only one. And then measure it. But then I do know which is which. And then it doesn't matter what I press or not, then I at least know which LED or if it works. And then the best thing is to use the probes, so 1, 2 and 3 values, or 1 and 3. 1 and 3 because 2 has 1 LED off. How to accomplish that? No, not here. Here. So I have to then block this one out. And I have to block this one out. No. Alright. Now they are all blocked. What I now have to do is it's not going right. Zero. No, not 0, because 0 means all off. Although I might just do that. I can keep it much simpler. Just copy these ones and change them. No separate algorithm needed. So then only this line is out and this line will be out. Correct. So now this one gets up to only 3. It's 0, 1 and 2. That should be then 4. 0, 1, 2 and 3. 1 is 1 LED, 3 is 2 LEDs. Yes. So this one counts down from 4 down to 0. Actually not entirely correct this. Yes it is. Yes. This doesn't do the same. This is the same. This is 0, 1, 2 and 3. This is 3, 2, 1 and 0. That is the best thing to do. And now hoping that this is going to work out. Compile, no errors, go. Oh, look at that. Wow. I have to change Alright, 5, and this should be then 5 volts. And see what happens right here. So that means it does work. It's a binary adder and all signals are there. But how high are the signals? This is 5 volts and they're only coming to 3 volts. And the block height goes from 5 to 2. So with a block 5 to 2, then 3 volts gets here, which is not nice. So I better leave it this way. And I should have these pointers at the line, and they are right now. So this is working. Which leads me to increasing the number, because then I want to know, but also why is it working now? Why didn't it work before? Alright, so time is almost running out, so I have to postpone the other test. What I wanted to show you is one of the first things that I started this episode with, this one. It is still not the resolution that I like to have. And well, I can press the switch, no use, because well, I can show, but it does work, kind of. But it's only these two LEDs that are working nicely, and you won't see it because of the wiring. So this is absolutely no use at this moment. This works, and well, considering the number of probes here, by the way, it is no use to increase the number to 4 because you won't see it on the scope. But I'm glad this works, but it makes me wonder for the rest of the LEDs, and why does it work now and not earlier? Alright, any more to say? Well, one thing more. I was talking about how the serial cable, of which is this the other end, is connected through a converter. Well, this is the other end of the converter cable. So this is the end of the, well, actually not from this experiment, but this is the other end of one of the cables. The real end for this experiment is somewhere somewhere out of view, but it's the same thing. Converter cable is the same thing, same model. Anyway, time to leave this program. Very handy, used it many times. And time to wrap up. So with these two LEDs working, I'm happy that I got it to work, and not satisfied by the way how. VLC with the delayed streaming video is still not clear to me why it quits full screen. But all things considered, yeah, nice experiment, nice results. Thanks for watching. If you like this video, please subscribe to my channel, give it thumbs up, the video that is, and leave a comment or suggestion, much appreciated. You can follow me on Twitter, and then please retweet, like it, leave a comment. You can also follow me on Instagram, please like it, leave a comment. You can show your appreciation and support by making a small donation via either PayPal or Wired. And you can also choose to become a patron and have your name mentioned. All voluntary, but very much appreciated. More information under this video with my Instagram and Twitter tag names, or whatever they are called, my website URL, and ways to donate. Thanks for watching, to be continued, and bye bye.